Okay, so hello everyone. In this video, we're going to discuss the concept of arc length. Now, sa arc length, in the simplest terms, it's actually finding the measure of a curve, no? If we were to get its measurement from one end to another. Or simply, pwede natin isipin na isi-stretch out or isi-straighten out natin yung curve, then hahanapin natin yung measurement nun. Okay, we're going to recall the distance formula. So if we have 2 points, x1, y1, and x2, y2, the distance between these 2 points is given by the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, we will make use of the distance formula to approximate or to get the value of the measure of the entire curve. Okay, so if we have a curve whose graph looks like this, now technically, any point on this curve can be expressed as xi, yi. Okay? Now, with the help of the distance formula, ang gagawin natin is mag-insert tayo ng mga intermediate points. So, ito yung mga yon. And then note na we took or we're going to take the distance between two consecutive points. So, from here to here, here to here, and so on. So, kung makikita nyo, it approximates the distance or the measurement of the entire curve. However, hindi niya nakaka-capture yung shape ng actual curve. So, ang gagawin natin is yung intermediate points, gagawin natin very, very close to one another hanggang sa makapture na natin yung itsura talaga ng curve. Okay, so let's take two consecutive intermediate points. Sabihin natin na lang na yung coordinates nun ay xi, yi, and x sub I plus 1, y sub I plus 1. Okay, if we get the distance between these 2 points by the distance formula, ang makukuha natin is x sub I plus 1 minus x sub I squared plus y sub I plus 1 minus y sub I squared. Now, these two values actually describe the change in x and the change in y respectively. So, pwede natin itong i-rewrite as the square root of delta x squared plus delta y squared. Okay? Now, we're going to manipulate this by factoring out delta x squared. So, if we factor out delta x squared, matitira sa delta x squared is 1. Tapos, sa delta y squared, we will actually get delta y squared over delta x squared. Now, examine yung nasulat nating mga expressions. Okay? Delta y over delta x, this is technically the slope. Or in terms of derivatives, this is actually dy over dx. And delta x, we can actually think of this as the differential of x. So equivalently, masusulat natin to as dx squared times 1 plus dy over dx squared. Now, simplifying, we have square root of 1 plus dy over dx squared times dx. Now, since ang gagawin nga natin is we're going to take these distances across all points in the curve. So, papasok na yung notion ng integrals dito. So, yung arc length formula natin will be L equal to the integral from a to b ng square root of 1 plus dy over dx squared dx. So, we will make use of this formula. Now, of course, pwede naman natin kuhanan ng measurement or ng arc length yung mga hindi functions. So, let's say we have a smooth curve along the y-axis. Ang gagawin lang natin is switch lang natin yung mga variables. So, or, yung arc length natin, pwede natin isipin as the integral from c to d square root of 1 plus this time dx over dy, or this is the derivative of x with respect to y, dy. So, kung alin yung mas appropriate or mas applicable, yun yung gagamitin nating formula. Okay, so let's solve some examples. Okay, let's say we want to find the arc length of y equals 3x minus 2 from x equals 0 to x equals 1. Okay, again, ang arc length formula natin is integral from a to b square root of 1 plus dy over dx squared dx. This is the graph. Yung a natin ay equal sa 0, b is equal to 1. Yung dy over dx natin, manggagaling siya dito. So, dy over dx, this is actually equal to 3. So, by substituting sa ating arc length formula, L equals the integral from 0 to 1 ng square root of 1 plus dy over dx squared dx. So, we have integral from 0 to 1, square root of 1 plus 9. So, that is square root of 10 dx. Apply FTC2. So, applying FTC2, we have square root of 10x from 0 to 1. This gives us square root of 10. Now, since this asks for the length, ang unit of measure natin ay units. I note, however, na line lang to. So, we can actually just use the distance formula and we should get the same answer. So, for the distance formula, we can consider the two endpoints. So, we have 0, -2, and 1, 1. Getting the distance between these 2 points. So, we have 1 minus 0 squared plus 1 minus -2. So, 1 plus 2 squared. That gives us square root of 1 plus 9, which is, again, square root of 10. Okay, so simple yung example na to kasi line lang siya. Now, suppose yung gusto natin kuhanan ng curve is not just a line. Okay, kumari, katulad nito. We want to find the arc length of y equals 2x raised to 3 halves from x equals 0 to x equals 1. Okay, kung mapapansin nyo sa graph, it's curved. So, hindi natin ma-apply lang ang distance formula. Kasi that just gives us the straight distance from, or straight distance between 2 points. Okay, kasi yung straight distance, that gives us the shortest distance. Okay, let's say we want to find the entire length of this curve. So again, using the arc length formula, L equals integral from a to b, square root of 1 plus dy over dx squared dx. We have a equals 0, b equals 1, and yung dy over dx natin, kukunin natin yung derivative nito. If we get the derivative, we have 3x. sorry, 3x raised to 1 half. Yan. Okay, and then again, we substitute sa arc length formula. So, integral from 0 to 1. Sulat na natin para mas obvious. So, dy over dx squared, this is equal to 9x. Integral ng square root of 1 plus 9x dx. So, again, we can approach this by integration by substitution. So, using integration by substitution, ang makukuha nating sagot will be 2 over 27 times 1 plus 9x raised to 3 halves. Then, of course, we evaluate this from 0 to 1. Evaluating from 0 to 1 will give us 2 over 27 times 10 raised to 3 halves minus 2 over 27 times 1 raised to 3 halves. 1 raised to 3 halves, this is just equal to 1. Yung 10 raised to 3 halves, we can think of this as 10 square root of 10. Okay, factor out natin yung 2 over 27. So, 2 over 27 times 10 square root of 10 minus 1 units. So, as you can see, since naging mas complicated na yung function natin, hindi siya direct application lang ng distance formula. Dito, gumamit na tayo ng integrals talaga. Or kailangan na talaga natin mag-resort to getting the integral. Okay, next example. Next example, we want to find the arc length of this function, y equals 2/3 times 1 plus x squared raised to 3 halves from x equals -1 to x equals 3. So, the graph is given here. Ito yung hahanapan natin ng length. So, we have a equals -1, b equals 3, and dy over dx. Get the derivative of this one. So, apply power rule and the chain rule. So, applying power rule, 1 plus x squared raised to 1 half times yung derivative na nasa loob, which is 2x. Okay, now, if we take the square of this one, this will give us, matatanggal lang yung 1 half dito na exponent, 1 plus x squared. Then we have 2 square 2x, so 4x squared. Or 4x squared plus 4x to the fourth. And we are now ready to set up the integral that will give us the arc length. So this one would be the definite integral from -1 to 3 ng 1 plus dy over dx squared. So, plus 4x squared plus 4x to the fourth dx. Now, this may look intimidating at first, but note that this one is actually 1 plus 2x squared squared. So, yung entire thing, kapag ginawa natin yung square root, matatanggal lang yan. So, we're left with the integral from -1 to 3 ng 1 plus 2x squared dx. Now, solving this is relatively easy kasi power rule lang ang gagamitin natin. So, we have x plus 2/3 x cubed. We evaluate from -1 to 3. So, 3 plus 2/3 times 3 cubed, which is 27, minus -1 plus 2/3 times Negative 1 cubed, which is negative 1. Simplify. So this will be 9. This is negative 1 minus 2/3 or 5/3. Then we have 3 plus 9. So 21. Sorry, 3 plus 2 times 9, 21, minus negative 5/3. 21 minus negative 5/3 will give us 63 plus 5 over 3 or 68 over 3 units. Okay, now for the last example here in getting the arc length, ang i-consider naman natin is yung isang curve na hindi function yung equation. Or isang curve na hindi function. Okay, let's say we want to find the arc length of x equals ln secant y from y equals 0 to y equals pi over 3. Now, if you graph the entire thing, makikita nyo na hindi siya function. Pero kinuha ko na lang yung section sa graph kung saan yun yung kukuhanan natin ng arc length. Okay? In this case, since ang given sa atin is yung y values, ang gagamitin nating arc length formula is yung in terms of y. So, L here will be equal to the definite integral from c to d ng square root of 1 plus dx over dy squared dy. C here is 0, d here is pi over 3, and dx over dy, kukunin lang natin yung derivative ng ln secant y. Yung derivative of x in terms of y. Okay? I note here na mag-chain rule lang tayo. So, ln secant y, ang derivative nito would be 1 over secant y times yung derivative ng secant y. Ang derivative ng secant y ay secant y tangent y. So, simplifying, maka-cancel yan. And yung dx over dy natin would just be tangent y. Now, if we take its square, yung derivative ng x with respect to y, squared, this is simply tangent squared y. Okay, so we now have everything we need in order to get the arc length. So, substitute natin. L equals the definite integral from 0 to pi over 3 ng square root of 1 plus tangent squared y dy. Now, solving this one, take note lang na by using Pythagorean identities, yung 1 plus tangent squared y, this is actually the same as secant squared y. Okay? So, magka-cancel out yung square root at yung exponent. We have the integral from 0 to pi over 3 ng secant y dy. And we have discussed the formula that will give us the integral of secant y. So, that is ln ng absolute value of secant y plus tangent y. Evaluate natin to from 0 to pi over 3. Okay, evaluating from 0 to pi over 3. So, this will give us ln ng absolute value of secant pi over 3 plus tangent pi over 3 minus ln ng absolute value of secant 0 plus tangent 0. Okay, secant of pi over 3, that is equal to 2. And tangent of pi over 3, that is equal to square root of 3. minus ln ng secant 0 is equal to 1 and tangent 0 is equal to 0. So we have ln ng 1 which is equal to 0. Now, since ito naman, sure tayo na positive yan, pwede na natin i-disregard yung absolute value dito. Okay? So we have ln of 2 plus square root of 3 units. Now, dun sa mga examples natin so far, ang ginawa natin ay kinuha natin yung arc length given yung x values or y values na nasakop ng curve. Now, meron pang isang concept, yung tinatawag nating arc length function. Now, the arc length function, this just gives you the arc length of the curve from a starting point. Okay? So the arc length function will simply give us, or will simply be given as s of x. Yun yung commonly used function name. Integral from a to x ng square root of 1 plus f prime of t squared dt. Arc length of the curve f from the point a, f of a, to any point x, f of x, na nandun sa curve. Okay, so kung babalikan natin yung mga examples natin, pero ang kukunin natin ngayon is yung arc length function. So suppose we want to find the arc length function of y equals 3x minus 2 with starting point x equals 0. So hindi naman mababago yung setup natin. However, this time, ang kukunin natin is yung f prime of x, isusulat natin siya as f prime of t. Okay? So s of x here will be equal to the definite integral from the starting point 0 to any point x on the curve, square root of 1 plus 3 squared dt. So simplifying, definite integral from 0 to x ng square root of 10 dt. Now, applying FTC2, this will give us square root of 10t evaluated from 0 to x, which gives us square root of 10x times square root of, minus square root of 10 times 0. So the arc length function is given by s of x equals square root of 10x. Okay? Note na pinapalitan lang natin ng f prime of t para mas clear na dapat x yung, in terms of x yung ating function. Now, with this next example, arc length of y equals 2x raised to 3 halves with starting point x equals 0. So again, kukunin natin yung f prime of x. F prime of x again is equal to 3x raised to 1 half. Isusulat lang natin to as f prime of t, which gives us 9, sorry, square ko na, which gives us 3t raised to 1 half. Now, since we want f prime of t squared, this gives us 9t. So, yung ating arc length function is given by the definite integral from 0 to x, square root of 1 plus 9t dt. So again, apply integration by substitution to get that this will be 2 over 27 times 1 plus 90 raised to 3 halves. We evaluate from 0 to x. So, evaluating from 0 to x, ang mangyayari lang ay yung t, papalitan natin ng x. Minus, at t equals 0. This is 2 over 27. 1 plus 0 raised to 3 halves. Now, 1 raised to 3 halves is just 1. So, the last step is for us to simplify this. Factor out natin yung 2 over 27. And then, may mantitira sa ating 1 plus 9x raised to 3 halves minus 1. So, this is the arc length function of the second item. And last, arc length function of y equals 2/3 times 1 plus x squared raised to 3 halves from x equals negative 1. Okay? So, f prime of x, again, is equal to 1 plus x squared raised to 1 half times 2x. So, f prime of t, papalitan lang natin yung x ng t. And then, we square this. This again gives us 1 plus t squared times 4t squared, or 4t squared plus 4t to the 4th. So the arc length function is given by s of x equals the definite integral from starting point is negative 1 to any point on the curve x, square root of 1 plus f prime of t squared. Okay, kung mapapansin nyo, bumabalik lang naman tayo dun sa paghanap ng arc length. Iba lang yung variable natin. So, the same can be said, or since na-solve na natin earlier on, pwede na nating makonclude agad na this is the same as 1 plus 2t squared dt. Pinalitan lang natin yung x ng t. Then, apply FTC2. So, t plus 2/3 t cubed evaluated from negative 1 to x. So we have x plus 2/3 x cubed minus negative 1 plus 2/3 raised to negative 1 cubed. This part here again will give us negative 5/3. So simplifying, we have x plus 2/3 x cubed minus minus, so plus 5/3. So this is the arc length function of the curve, of the given curve, from x equals negative 1. Okay, so in this video, again, to summarize, we've discussed how to get the arc length of a curve, as well as the arc length function given a starting point on the curve.